Hello students, I am Ashish De. I am taking one of your subject, that is digital communication. In my earlier video, I have drawn some line coding waveforms. Okay. In this video also, I want to redrawn some waveform on different data streams. Okay. So the waveforms are basically taken from line coding techniques. This video is to be useful, very useful for your semester exam, because these are very important. That's why I am taking many classes on this waveform drawing. Okay. Now suppose the data stream is given by suppose the data stream is given by 1 0 1 1 0 0 1 1 0 1 0 1. Okay, so each bit is divided by separate cells. Okay. Now at first we have to draw some dotted lines for the bits for each cells. Okay. This is the dotted line taken from half of the bit portion as shown in the earlier example. Okay. Offset करो. So this is the binary data sequence. Okay, now we have to draw unipolar return to zero type waveform. Okay, so for drawing unipolar return to zero type waveform, minded this is return to zero type. Okay, and this is in along x-axis, this is time axis, and this is the amplitude axis. Okay, for unipolar return to zero type, the first half of the bit, that is 1, the amplitude will be a, and in the next half of the bit the amplitude will be 0. Okay, again when it is 0 there will be no amplitude. Okay, again whether again when the bit is 1, then in the first half of the bit the amplitude will be a, and in the second half there will be no amplitude. This will repeat for the next bit of 1. When it is 0 there will be no amplitude. Again here will be the amplitude of a. Okay, here is also the amplitude of A. Here is 0, so there will be no amplitude, and here will be the amplitude of A. Again here will be the amplitude of A for the first half of the bit. Okay, so this is the waveform for unipolar return to zero type, right? Now when it is not return to zero, then what will be the waveform? When this is not return to zero, the waveform looks like this. This is time axis. Okay, when it is not returned to zero, the amplitude will be for the entire bit. So this will be the amplitude. Here is 1, so amplitude is A. When it is 0, so the amplitude is absent. Again when it is 1, the amplitude will be A, but it continues up to the next bit, because the next bit is also 1. Okay, and it does not return to 0 anywhere. Now the two bits, successive bits are 0, so there will be no amplitude. Again here will be the amplitude of A. Okay, now there will be no amplitude. Again this will be the amplitude of A. This will be the amplitude of A. Okay, so this is unipolar non-return to zero type waveform. Okay, now bipolar return to zero type waveform. In this type, when it is returned to 0, then the first half of the bit there will be a positive amplitude, since the bit is 1, and in the next half the amplitude will be 0. But when it is 0, then the amplitude will be minus A. Okay, this will be minus A, and it is returned to 0 when in the second half of the bit. Okay, again when it is this is A by 2, amplitude is A by 2, here is minus A by 2. Okay, now when it is also, when it is 1, then the bit will be A by 2 plus A by 2 in the first half of the bit, and this is 0 in the second half. This is A by 2, right? Now when it is 0, then it will be minus A by 2, and it will return to 0. Again minus A by 2, and it returns to 0. Okay, when it is 1, this will be plus A by 2, this will be plus A by 2. Okay, and it returns to 0 in the second half. Again when it is 0, this will be minus A by 2, and it returns to 0 in the second half. Again this will be plus A by 2, here will be minus A by 2 because it is 0. Now it is 1, so this will be plus A by 2. Okay, so this is the waveform of bipolar return to zero type. Bipolar return to zero type waveform, RZ waveform. Okay, now split phase Manchester type coding. We know for split phase Manchester, the drawing will be when the bit is 1, in the first half of the bit it will starts from the positive A by 2 to negative A by 2 when the bit is 1. Okay, so this is positive A by 2, and this is minus a by 2. Amplitude is minus a by 2. Okay. Now when the bit is 0, then it will starts from negative a by 2 and it goes up to positive a by 2. Remember that split phase Manchester and Manchester type coding are same. Okay, now here is also 1, so it will continue up to here and it will goes up to here again. This, now it will continue up to here and this, this from negative to positive, since the bit is 0, again the bit is 1, so positive in the first half and negative in the second half. Again the bit is 1, so positive in the first half and negative in the second half. Now the bit is 0, so negative in the first half and positive in the second half. The bit is 1, so positive in the first half and negative in the second half of the bit. Okay, now this is 0, so negative in the first half and positive in the second half of the bit. Again it continues up to here, this portion. Okay, so this is basically split phase Manchester type of waveform. Split, SPLIT, split phase Manchester or simple Manchester format. Okay, so Manchester format, split phase Manchester format or simple Manchester format. So what we learn from this video, we learn different types of line coding formats for return to 0 and non-return to 0 type waveform. Okay, for in case of unipolar, the amplitude will be the full amplitude, that is A. It does not have the negative amplitude. Okay, but in case of bipolar, there are the amplitude is divided by A by 2 in the positive side and negative side also. Okay, so this is positive A by 2 and negative A by 2. Okay, and in split phase Manchester type coding, there are special format. When the bit is 1, it will starts from positive half and goes up to the negative half of the amplitude of the bit. Okay, but when the bit is 0, then it will starts from negative half and goes up to positive half. Okay, so practice some examples from the books of Sanjay Sharma, communication system. Okay, some waveforms that are very important for your exam.